Happy Monday of week 2. Happy Monday of week 2, ladies and gents. I hope last week math went well. Apologize for the Schoology issues, but hopefully they are getting on it so that things go better this week. Um, we are looking at 8-4, which is multiplying in special cases with polynomials. And the first situation we're going to look at is sum and difference. Number 1 is the following. It's n plus 2 times n minus 2. So we have two binomials being multiplied by each other, and one is an addition and one is a subtraction. So a couple ways you can do it. Remember, we do have the area model, and you can use that in these cases. If you're a visual person, this is a good thing to use. So I am going to put the n, and this is a plus 2 and n minus 2. I will multiply the n times the n to get an n squared. I will multiply the n times the 2 to get a 2n. The negative 2 times the n to get a negative 2n, and negative 2 times positive 2 gives me negative 4. And you'll notice if we combine these like terms, I'm going to end up with an n squared minus 4. The 2n minus the 2n will make a 0, and they will cancel when I collect like terms. So cancel when collect like terms. Kind of the bonus of having a sum and a difference. If you want to do it by the FOIL method, remember we take first times first, so that is your n squared. Then we do the outside, that's the O part of FOIL. N times negative 2 is a minus 2n. Then we take the inside, which is a positive 2 times an n, so plus 2n. And then we take last times last, which is the L part of FOIL. And that's going to be a positive 2 times a negative 2. Again, collecting like terms, those go away. And we get an n squared minus 4. So let's try our next one. N plus 3, n minus 3. I don't care which one you use. You can do the area model like we did over here, or you can do FOIL. I'm going to choose to do FOIL just because it's less writing, but this one is just as legit and works just as well. N times n is n squared. That's my F part of FOIL. The outside terms are n and negative 3, so that's a minus 3n. My inside terms in FOIL are 3 and n. That'll become a plus 3n. And my last terms in FOIL are going to be positive 3 times negative 3, which is negative 9. Again, collect your like terms if you have any that you can collect, and write what's left over. N squared minus 9 should be your answer. Okay, our third one, I'm going to ask you to factor. Okay, so let's say that you have something that equals n squared minus 25. How are we going to factor? Well, we're going to go backwards, and you'll notice this is the same pattern that we have here. We have something squared, and then we have a perfect square number in the second position of this quadratic binomial. So I'm going to say this is going to be an n plus 5, because 25 is a perfect square number. I can split it into 5 times 5. And this would be my factored form. So this is a work backwards one right here when you have the product and we want to find the factors. Okay, moving on to number 4. What happens if we throw in a quadratic binomial? Maybe quadratic means to the second power. Binomial means there's 2 terms. So now we have 2 quadratic binomials being multiplied. Again, we're going to use FOIL. First times first, x squared times x squared is x to the 4th. Same base, different exponents, add the exponents. The outside is going to be a negative 6 times an x squared, so minus 6x squared. The inside will be a 6 times an x squared, so plus 6x squared. And the last will be a positive 6 times a negative 6, which is negative 36. Again, we'll look to collect our like terms. those two items will add up and make 0. So we have no x squared terms here. We have an x to the 4th, and we have a minus 36. So we have a quartic because it's to the 4th power, binomial because there's two terms. Same idea. All right, this one I'm going to ask you to factor. Okay, so we have an x to the 4th minus 81. And we want to work it backwards and figure out the two binomials that we can multiply together to get this. Well, first of all, what times itself gives me x to the 4th? That's an x squared times an x squared. And then look here, you've got an 81, that is a perfect square number. That is 9 times 9. And I want a positive and a negative because the middle term is going to cancel out like we see up here. And here and here. So there is your factored form. All right, number 6. Little different, 38 times 42. So let's say that we have something like this. If I'm going to do kind of quick mental math, I see 38 and 42 are both really close to 40. So I could rewrite this as 40 minus 2 and 40 plus 2. 40 minus 2 is 38, and 40 plus 2 is 42. Now, why would I do that? Well, this is kind of getting us into our general form for factoring something that's a sum, has a sum and a difference. So our A in this case is going to be 40, and our B is going to be 2. So general form for these guys is this. If you have, well, let's finish this first. 40 is my first term, that's the A, and 2 is my last term, and I'm going to square that. I'm going to take my first term and my last term and square them both. It's kind of what we were doing here. First term squared and last term squared. First term is squared, the last term is squared. And 40 squared, if you work it out, is 1,600, and we take away 4, you get 1,596. If you check that on your calculator, you will get the exact same answer. This is just a quick mental math way to do these problems, and it's handy. So worthy of bringing to your attention. So sum and difference, what do? The general form for a sum and difference when you multiply two binomials is this. I'm going to let the first term be A and the second term be B. And you'll see we got something plus and something minus. And what will we get in the end? It's going to be the A term squared minus the B term squared. A term squared minus the B term squared. So that's kind of our general form. All right, let's keep moving on. Square of a binomial. Okay, so let's just say that you get something like this. Okay, and it's not written out longhand, okay? One way I could do this is I could do x plus 8 times x plus 8, because x plus 8 squared really means take two of these x plus 8s and multiply them by each other. And then I could FOIL after that and draw my arrows and work it out. However, I think it's easier to use kind of this formula here, but it's a little different when you have something like this. So let's do this first one and FOIL it and see if we notice a pattern. Okay, if I'm going to FOIL this, the first times the first, x times x is x squared. The outsides would be x and 8, so plus 8x. The insides would be 8 and x, so plus 8x. And 8 times 8 would be our last. 8 times 8 is 64. Collect your like terms, we get x squared plus 16x plus 64. That is a quadratic trinomial. Okay. Number 8. What if we have subtraction? X minus 6 squared. Well, that's going to be the same as taking x minus 6 times x minus 6. And if I FOIL it, first times first is x squared. Outside would be x and negative 6 minus 6x. Inside would be negative 6 and x, which is negative 6x. And last terms would be negative 6 and negative 6, which makes a positive 36. X squared minus 12x plus 36. Okay. So let's look at our next item. Number 9. We are going to do 3n minus 1 squared. Now, we'll keep going with this. What does that mean? That means take this binomial and multiply it by itself. So, first, 3n times 3n is 9n squared. Outside, 3n times negative 1 is negative 3n. Inside, negative 1 times 3n is negative 3n. And last, negative 1 times negative 1 is 1. So we get an 9n squared minus 6n plus 1 as our final answer. And last but not least, we're going to look at 49 squared. Let's say you just have a plain old number and you're going to square it. How can we do it in an easy mental math way? Well, 49 is really close to 50. So I'm going to rewrite it as 50 minus 1. And if I do that, let's see here, I can probably take 50 and square it, which is the a term, and the negative 1, okay, I am running out of time, so I'm going to quit this and do a second part to this.